A right triangle. Good. Take a point. You only use it on a right triangle. You can only use this on a right triangle. But you can use it to prove that a triangle is not a right triangle. Now, please draw for me a right triangle down here in the bottom corner. Now, we know that it's a squared plus b squared equals c squared, but what do the a and the b represent?
The area of the base. The bottom.
So the a and the b represent the legs. This would be our a, this would be our b. The hypotenuse is always your c, always. And who also remembers a fun fact about the hypotenuse?
It's the line across from the right.
The line across from the right angle, and it's also the longest side. Good, both of you take a point. All right, so A is a leg. It is a leg of a triangle. You don't have to. All right, is B also a leg? B is also a leg. It's also written on the board back there. All right, and what does C represent? If A represents a leg, B represents the hypotenuse. And for those of us who don't know how to spell hypotenuse, Hypotenuse. Hypotenuse. So leg, hypotenuse. And what do you do with those leg lengths when you plug them in? You square them. Take another point. Which means you multiply the number by itself. In noose. Hypotenuse. Alright, so the way you know that it's a right triangle is if you add a squared and b squared together, it has to equal c squared. It has to equal c squared. What, darling? Yep, that's all we've written down so far. Stop that, whatever that is. Because I say stop it, whatever it is, doesn't mean keep doing it. Geniuses.
Sean Paul.
Here. It better not be you, son. Alright, so what we're going to do is we are going to do these top two problems, and we're going to determine the missing side lengths. So there's two ways that you can do it. You can do it to the nearest tenth if it's not a whole number. You can leave it in simplest radical form if it's not a whole number, and we're going to learn how to do both. Are you ready? First, draw a box, and that's how you know it's the right triangle, because we can only use the Pythagorean theorem on what kind of triangles?
Right.
Fantastic. We're going to let this be 9.4 centimeters. We're going to let this be 14 centimeters. And we're going to call this x because it's our unknown.
I didn't say Sean Paul.
Alright, so what you do to find a missing side length is you plug it into the Pythagorean theorem. And it doesn't matter if you plug x in for A or 9.4 in for A, as long as 14 is C. So you have A squared plus b squared equals c squared. So we're going to let x be a. And we're going to say x squared plus 9.4 squared equals 14 squared. All we did was plug in our side lengths. Does everybody understand?
Yes, ma'am.
Fantastic. Yes. Well, it's not B2 because we're not old ladies playing bingo. I would rather it be, it doesn't matter, but if it's asking for X, put X.
Okay, so I got a question.
You have a question?
Why did you choose it to go inside A?
It doesn't matter. It does not matter if it goes with A or B because both of these are your legs. So it does not matter which one we put there. And we'll work it out differently over here to show you. It does not matter. All right, what is 9.4 squared? Hey, just because I pause for a second to answer a question doesn't mean that you start talking. Does everybody understand?
Yes, ma'am.
18.8.
88.36. You square it, baby, not times 2. Not you, Mazzaro. Her.
28.8.
And what's 14 squared?
196.
Am I done?
No.
I have to subtract. I subtract 88.36 from both sides, and I get x squared equals what?
107.
All right, how do I get rid of a squared? Because we talked about that in our math workshop. Square root. Square root both sides, and remember, we're rounding to the nearest tenth in this. Rounding to the nearest tenth. So it's the square root of 107.64. Ten 10.4 what? Centimeters. Take a point.
Hold on. You square 107?
Look, it says 104.
10.4. Why would it be 104 if we're taking the square root?
Miss Johnson,
10.4. What?
what did you do? You just squared x and 107?
I took the square root of both sides. May I borrow your calculator, Nakia, so I can show him what buttons to press? So for those of us that don't know what buttons to press, you hit second and x squared. That gives you the square root. And then you type in 107.64. And then we round it up to 10.4.
Oh, yeah. There's a 7 and then a 3. I got you.
Okay. Any questions so far? Now, what does simplest radical form mean?
I have not heard that one.
Small as it can be.
Ish. Is there going to be a radical in our answer?
Yeah.
Yes, because it's simplest radical form. And we have done this in our math workshops. We did it every day for like at least 2 weeks. Now, simplest radical form means you need your perfect square card, in case you still have it. If you don't, I have mine. And you're going to find the biggest perfect square that divides into our number. And remember, the perfect square are the pink ones. So we're going to work this problem out. I let my side length be x, 8, and 12. And my hypotenuse is 12. X, 8, and my hypotenuse is 12. What?
Oh, geez.
All right, now we're going to plug it into Pythagorean theorem. Does it matter what we let be a?
No.
But this time we're going to switch it up and let it be 8 squared plus x squared equals 12 squared. It is still the same thing. All right, what's 8 squared?
64? Yes, I got that right. Oh, I'm so
What's 12 squared?
sorry. 44.
144. So close. Close only counts in horseshoes and hand grenades. All right, what do we do from here?
Subtract 64.
Okay, so what's 144 minus 64?
80.
And now,
Square
square root. Awesome. Now, are we going to plug it into our calculator this time, or are we going to use our card?
We ain't gonna plug it out.
We're going to use our card. Now, what do you think, and we're using the pink column, is the biggest perfect square that divides into 80?
9.
8 is not a perfect square.
Oh, 80.
Pink column.
64.
Okay, do 80 divided by 64 and tell me if you get a whole number.
No, it's 4. 16.
16. Look at you go. So everybody do 80 divided by 16. Tell me what you get.
5.
You get 5.
Oh, 9.
All right, so that breaks it down into 16 and 5. Do you guys remember us doing this?
Oh.
The biggest perfect square.
Oh, and then it's 4.
And then it's 4. Where do we get the 4 from?
16.
Because the square root of 16 is 4. So it's 4 root 5 inches. That's it. That's all you do.
I think I like the other one.
Perfect squares just take practice. We're going to do both. Now, there is also some magic that happens with the Pythagorean theorem with specific whole numbers. I want you to turn to the next page because we're going to write them down. They are called Pythagorean triples. We're going to write it on 52B. So you don't need to write it on the back of this. Don't write it on the back. Because you have to glue it down, baby. You're not going to be able to see it.
Oh, yeah.
But do what you want to do because I can't anymore with you.
But I don't have any more
Just do
paper.
what you want to do, baby.
Do you need a sheet of paper, Chantal?
Yeah, I put it out. So I can do this as this.
Both of them?
All right, Pythagorean triples. Now, a triple means that it is a squared plus b squared equals c squared. It means whenever you add the first two together, after you square it, you get the third one squared. And the largest one is always called what? It's not a leg. Hypotenuse. Take a point. Are we ready or do we need a mo? Okay. You get real confused when what?
When you do your letters like that and I try to copy it, then it's not very well.
I just practice.
But I like it.
Would you like me to teach you how to do that one day?
Yeah, me too.
Okay.
I think we just draw one. It's the same color. It's okay.
Could do like a handwriting afternoon. That would be fun.
Good thing she knew what I do.
Please don't make me throat punch you.
I didn't say anything before people.
I'm sure that is not a true statement. I'm sure that is not a true statement. All right, so you have 4 kinds of triples. You have 3, 4, 5.
Wait, do you know how to do calligraphy?
A little bit. Calligraphy? Yeah. 5, 12, 13. 8, 15, 17. And 7, 24, 25. Now what this means is if you do 3 squared plus 4 squared, it's going to equal 5 squared. That's what makes a triple. And let's prove it. What is 3 squared? What is 3 squared? 9. What is 4 squared?
16.
Thank you, Trey. And what is 5 squared?
25.
What's 9 plus 16? What is 9 plus 16?
25.
25. Does 25 equal 25?
Yeah.
That makes it a triple.
That's it.
That's it. So if I give you a triangle and I say find the missing side length and it's 3, 4, you better know that that side length is 5 without doing the Pythagorean theorem.
That's more simpler than doing a square plus b squared plus c squared.
But it, squirrel?
Square.
squared.
Mine says square.
I think it's squirrel.
Are these the only triples we're gonna deal with?
No. You want to watch this trick I learned in NOM and see what happens? If you multiply this by 2, you get 6, 8, 10. That's also a triple.
Way.
If you multiply this by 2, what's 5 times 2?
10,
What's 12 times 2?
24,
13 times 2?
36.
26. That's a triple.
Ooh.
Alright, what's 8 times 2?
16.
What's 15 times 2?
30.
17 times 2? 34. That's a triple. Alright, what's 7 times 2? 24 times 2?
48.
25 times 2?
50. Got it.
Those are triples. All you have to do is memorize them. And the base form of it, and it can be any number or any multiple of 3, 4, 5. So you can do 3x, 4x, 5x.
Do we have to do this every time?
No, this is only if it gives you these side links.
Okay,
What if we don't know?
Well, we're going to talk about that.
why did you do 9 plus 16?
So this one will be.
If all you did was-
Baby, it's proving that it's a triple. It's proving that it's a triple. This is the Pythagorean theorem, which is a squared plus b squared equals c squared. This is your a, this is your b, this is your c. So a squared, 9, plus b squared, 16, must equal c squared, 25. And 9 plus 16 is 25. Boom, it's a triple.
Is that what you do for this one?
Yep. What are you confused on?
I'm just not caught up. I haven't.
Okay. So why don't we finish writing down our triples, because you're going to need to know these in case I give you a test on them. Well, it would be a free grade of just memorizing your triples. So I don't know why or a combination of 3x, 4x, 5x. So if I plug in 4 right here, 3 times 4 is, 4 times 4 is, 5 times 4 is,
20.
that's a triple.
Do we do the 6, 8, 10, x is 2?
No, this is your base one. So here we multiplied by 2, right? To get to this level, we just took our triple and we multiplied everything by 2. Now the way you use it is if I give you a triangle, and let's call this triangle A. And I say, I want you to find the missing side length x. And I give you that this is 8 and this is 17. Well, normally we would do the Pythagorean theorem, or we could look for 17 as a hypotenuse. Do we see 17 as a hypotenuse anywhere up there?
No. Yes.
Right here, correct? Third row? What would the missing side length be if I already have 8 and 17? 15. You're done.
What?
Can we look at this and things?
Maybe?
Yes. We can make a flashcard?
Maybe?
Where did you
Ooh.
Okay, so I said 17 is my hypotenuse, and I looked up here at my triples.
You can keep talking. I was listening.
Okay. Well, did you understand where I got 15 from, or you want me to explain it again?
You don't explain it.
Okay, I saw that 17 was my hypotenuse because it's across from the right angle, correct? And then I looked up here for 17 as the hypotenuse. The hypotenuse is the biggest number, so I looked for a triple with 17 as the biggest number. It was right here. It gave me 8, so that means I'm missing 15. X is 15. That's it. That's all you do. So what if I give you one that looks like these? And I say 25 and 7. And I want you to find x.
24.
Why is it 24?
That found it up.
Because that's your triple. And in case you don't believe me, we can use the Pythagorean theorem to prove it. So we would have 7 squared plus x squared equals 25 squared, correct? If we were using the Pythagorean theorem. All right, 7 squared is 49. 25 squared is 225. No, 25 squared is 625. I got excited. All I did was plug my side lengths into the Pythagorean theorem. That's it. Nothing crazy. Alright, then what do I do from here?
You subtract.
I subtract, and I get x squared equals what?
576.
And then what do I do to get rid of my squared? And what's the square root of 576?
24.
Boom. Or you can know your triples.
I'd rather know my triples and go for it.
Okay. Now, what if I give you a triangle? Ugh, the belly is in the way.
Do you put like
Like it's like
Not yet.
Do you eat cereal only or eat cereal off the stomach?
Do I eat cereal off my stomach? I do not eat cereal off my stomach.
I would.
It's not that big yet. Alright, so what if I gave you x, 2, and 5?
Okay.
Or, now we know 5 is a hypotenuse, is a triple, but is 2 part of that triple up there? So what would we have to use to find our missing side?
Try A squared, Pythagorean theorem.
Pythagorean theorem. So we would do x squared plus 4 squared equals 25 squared. Ah, Blair, 5 squared, not 25. Which is 25. Ham sandwich, Blair. I got excited. Thanks. Okay, that's better. I'm finally there.
God bless you.
Alright, then what do I do? And you get x squared equals 21. And then I take the square root, and what's the square root of 21?
7. 4. 6.
Because this is supposed to be a squiggleed out, and this is supposed to be a 2.
There we go. Hurry up.
Alright, last part and then homework.
Homework.
Yes, work that you do at home. Yeah. You have to watch the video. Alright, the converse is... Yes, Grace, I know. The converse is, you can also prove that it's a right triangle by using the Pythagorean theorem. So if I give you side lengths of 10, 24, and 26, you have to use this to prove it's a right triangle. We don't know that it's a right triangle, so we're going to do 10 squared plus 24 squared equals 26 squared. Now what happens is, you come over here, if this is less than c squared, it's an obtuse triangle. If it's greater than, it's an acute triangle. Tonight, you need to do these two for homework and finish this one up top. So you're doing this one, and finishing this one. I'm about to put it on there right now.
I can subscribe to that.
Yes.